Hello student, welcome to Study Doubt. In this video, we will study about the sign convention of spherical mirrors. So in spherical mirrors, we have to study about concave mirror and convex mirror. So first we start with the concave mirror. As you see in this diagram, we have a concave mirror. This is the pole, principal focus, center of curvature, radius of curvature, and the focal length. In sign convention, right side of the pole is considered as positive. Left side of the pole is considered as negative. Upside from the principal axis is positive and downward direction of the principal axis is negative. We can also understand this with respect to the coordinate geometry. If we consider this point as the origin, so here you can consider it as a pole, and this is the x-axis and here is the y-axis. So right side of the x-axis is positive x-axis and left of the x-axis is negative x-axis. Similarly, with respect to y-axis, upward direction is positive y-axis and downward direction is negative y-axis. If we place this coordinate with respect to the pole, now you see this up is considered as positive, same it is matching with this. Down is considered as negative, it's negative. Similarly, positive of x-axis is positive and the negative of x-axis is negative. So by this way, we can easily identify the sign convention of a concave mirror. Let's understand with example. We know that concave mirror can form real image as well as virtual image. So first we will see how the sign convention is formed due to the real image. So here I take a ray diagram between the center of curvature and the principal focus. So based on that, this is the ray diagram we formed here. The image is formed beyond center of curvature. It is magnified, real and inverted. Here AB is the height of object and A dash B dash is the height of image. Similarly, the distance between A to P is represented as U, a small u, and the A dash to P, it is represented as a small v. We know that the distance between P and F is the focal length, it's a small f, and the distance between C and P is capital R, it's radius of curvature. All the terms are mentioned here. Now we have to write down all the terms in this table. This is the u, it means that it's a distance between A to P. Here it is V, the distance between A dash P. F is the focal length, it's the distance between focus and the pole. Height of object is A to B. And this is A dash to B dash, and the radius of curvature is C to P. Now you notice, based on our sign convention that we have studied previously, U is lying on the left side of the x-axis, so it is considered as negative. V is also on the left side of the pole, so it is considered as negative. Focal length also lies on the left side of the pole, so it is considered as negative. Height of object is on the positive direction of the y-axis, so it is considered as positive. Height of image is along the negative direction of y-axis, so it is considered as negative. And the radius of curvature, it's on the left side of the pole, so it's considered as negative. So whenever we have real and inverted image for a concave mirror, we always follow this sign convention. Now we'll see how the sign convention is formed for the concave mirror of virtual image. This is the ray diagram of a concave mirror where the image is formed virtual image. So we know that when the object is lied between focus and the pole, then the image is formed virtual image. Its nature is magnified, virtual and erect, and it is formed behind the mirror. So again, AB is our height of object, A dash B dash is height of image, P to A1 is the distance between image and the pole, it's represented as V, and A to B is the distance between the object and the pole, it's represented as U. C and P is the radius of curvature, and F and P is the focal length. So you see here, U lies where? U is on the left side of the pole, so it is considered as negative. V is on the right side of the pole, so it is positive. Similarly, focal length is on the left side. This is on the left side of the pole, so it is negative. Height of object is on the upward direction of the y-axis, so it is positive. Similarly, height of image is also on the upward direction of the y-axis, so it is considered as positive, and the radius of curvature is on the left side, so it is negative. So this table is a sign convention of a concave mirror for the virtual image. Now we will see the convex mirror sign convention. Let's look into the convex mirror sign convention. Here is our convex mirror. This is the pole. Here is the principal focus, center of curvature. The distance between principal focus and the pole is focal length, and the distance between pole and the center of curvature is radius of curvature. Rule is exactly same. If we place these coordinates here, so we notice that right side is positive, left side is negative, upward direction is positive, and downward direction is negative. Rule is exactly same. But what is changing here? The position of focus, center of curvature, focal length, and radius of curvature. Because of this, sign convention will change in convex mirror. So let's take an example for better understanding. We know that in the convex mirror, the image is always virtual and erect. In convex mirror, we have no real image. So if we take an example, here is a ray diagram of an object which lies between infinity and the pole. And we know that according to this ray diagram, the image is diminished, virtual and erect, and it forms between P and F. So if the height of the object is represented as AB and the A dash B dash is the height of image, P to F is the focal length and P to C is the radius of curvature. So let's understand what is the sign convention in this case. We know that U is the distance between A to P and it lies on the left side of the pole, so it is considered as negative. Similarly, V is the distance between image and the pole, is the distance between A dash and P, and it lies on the right side, so it is considered as positive. Focal length. Focal length in this case is always on the positive side, and the height of object is upward direction, so it is considered as positive. Height of image is also on the upward direction, so it is considered as positive. Radius of curvature is on the right side, so it is considered as positive. So you notice that in the concave mirror sign convention, only U is negative, rest all the terms are positive. So it's easy to remember. So now we will see the magnification sign convention based on concave and convex mirror. We know that magnification formula is height of image by height of object. So if we consider for a concave mirror where the real image is formed, so we know that in real image height of object is always negative and the height of image is always positive. So positive divided by negative is always negative. So when the magnification is negative in sign, so it means it is always real and inverted. Similarly, for the convex or the concave mirror where we are taking a virtual image, in this case magnification will be positive. Because both height of image and the height of objects are positive, so we get the magnification as positive. From here we can say that when M is positive, that time it is virtual and erect image. Let's try one question based on this concept. In this question, it is given that which mirror we are using when magnification is +1, magnification is +2, and magnification is +1/2. So we studied just now, when the magnification is positive, it means it's virtual and erect. And we also know that magnification formula is height of image by height of object. So if we consider the first case when the magnification is +1, so here in the first case M is equal to +1. So plus represents virtual image. And what is the meaning of 1? If I say m is equal to plus 1 and is equal to height of image by height of object, from here we conclude that height of image is equal to height of object. And second thing, what we conclude? It is virtual and erect. So based on these two information, we can say that in the first part, it is a plane mirror. Why it is a plane mirror? Let's understand in detail. If we consider concave mirror, convex mirror and the plane mirror, convex mirror always forms the virtual image and it is dimness. Concave mirror can form virtual as well as real image. When it forms virtual image, then it is always magnified. And if we see the plane mirror always forms virtual image and it is same size. So if we say same size means height of image is equal to height of object. So if we look into the first option, m is equal to plus 1, so plus means it's virtual and 1 represents height of image is equal to height of object. So based on that we can say that it is a plane mirror. Now second example, B part, magnification is equal to plus 2. So what is the meaning of plus 2 here? It's virtual and erect, that's confirmed, and 2 means it's a magnified. So here height of image is 2 times of height of object. So which of the mirror can form virtual and magnified image? It can be only formed by the concave mirror. So for the B part, we can say that it's example of concave mirror. In the C part, magnification is plus 1 by 2. Plus means virtual and 1 by 2, it is dimness. So now we can say that for this convex mirror can form virtual as well as dimness image. For the C part, the correct option is convex mirror. For better understanding of the sign convention, you can practice some of the questions given here. These questions you can practice and write your answer in the comment box. If you like this video, do subscribe it, like it and share to your friend. Thank you.